Hello, and welcome to Foundations for Algebra, Unit 3A, Lesson 7. Today, scholars will use the Pythagorean theorem to find missing lengths in real-world situations. So, we're using the Pythagorean theorem. You do not have to be able to spell it. So, the Pythagorean theorem says that for a right triangle with sides A, B, and C, the hypotenuse, the relationship a squared plus b squared equals c squared is always true. We looked at this in lesson 6, where we looked at these to decide if they were right triangles. So now I'm going to tell you, yes, they are right triangles, because you guys have done this. So we have this side. So you guys have dealt with the converse. If A, B, and C are the sides of a triangle and a squared plus b squared equals c squared, then the angle that is opposite of the right angle, which is called the hypotenuse, will always be equal to the side length squared. Okay, so in this case, I've given you 3 side lengths. My question, is this a right triangle or not? So I have the side lengths 8, 6, 8, 6, and 10. So I have those side lengths. So we're going to decide this is the right triangle. So my sides are 6. Undo that. Go back to here. So see, my side lengths, I have 6, 8, and 10 is my side lengths. 10 is across from my right angle, so that must be my side C. It's also the longest, so that must be side C. That one we have to identify. So is 6 squared plus 8 squared equal to 10 squared? Well, 6 squared is 36. 8 squared is 64. 10 squared is 100. 100 equals 100. So, yes, this is a right triangle. That's what we did in our last one. Let's look at this. So now, instead of me giving you the 3 sides, I'm asking you to find this missing side here. The side we're trying to find is our hypotenuse, because we are across from our right angle. Now, I am going to tell you that all of these, if I don't tell you, they are right triangles. So we have to use our Pythagorean theorem. So I'm going to write 15 squared plus 40 squared equals, and choose a letter for this. We can call it C. We can call it X. It doesn't matter. So right now I'll call it C squared. Well, 15 squared is 225 plus 40 squared is 1600 equals C squared. If I add those together, I get 1825 equals C squared. Now, in order to solve this, I'm going to take the square root of 1825, and you can do this. If it's a big number like that, you can do this on your calculator, equals, not C squared, C. This is our exact answer. So that is our exact answer. We can also give an approximation. So if you put that into your calculator to find out what the square root is, we'll find out that the square root of 1825 is 42.72. Is approximately equal. That's what those little curvy lines mean, equal to C. That's our approximate answer. And that we just put into our calculators, and then we're round to the 100th place. So that's our approximate answer. So let's look at another one. Okay, one thing to notice here. What side is missing? You'll notice my right angle is right there. That means this side is my hypotenuse. No matter which way my triangle is facing, the side across my right angle is always my hypotenuse. So again, I'm going to write 3 squared plus 6 squared equals C squared. Well, 3 squared I know is 9. 6 squared is 36 equals C squared. So 9 plus 36 is 45. If 45 equals c squared, we're going to take the square root of 45 is equal to c. Again, this is our exact answer. And for these, I'd like you to give me both the exact and the approximate answers. If I put it into the calculator, I can see that it is approximately 6.71 is approximately equal to C. Okay, let's try another one. Okay, let's try another one. 13-foot ladder. A 13-foot ladder is placed 5 feet away from a wall. The distance from the ground straight up to the top of the wall is 13 feet. Will the ladder reach the top of the wall? So you'll see I have a nice little diagram here, and I'm going to try to label these. So I see my triangles right here. I use the bottom of my triangle. Here's the side of my triangle, and here's the hypotenuse of my triangle. We're going to assume that's a right triangle. So what information do I know? I know I have a 13-foot ladder, so that means this side is 13. I am 5 feet away from the bottom, so the bottom down here is 5. The top of the wall is 13 feet. So over here, let me make this, a little bit thicker so you can see it a little better. Maybe. Is a 13 foot. Okay, so now we need to use these numbers to try to solve this. So, I have 5 squared plus 13 squared equals 13 squared. That's what I'm trying to figure out at least. Well, 5 squared is 25. 13 squared, if you put it on your calculator, is 169. 13 squared is 169. Well, 25 and 169 is 194 equals 169, which is not true. So, no, it will not reach the top. It'll look something like this picture where the ladder only goes up partway up the wall. Let's try another one. In this case, I didn't give you a picture. We're going to draw a picture to go with this one. So, a soccer field is a rectangle. Well, that's true, right? So let's draw a rectangle. Soccer field is a rectangle. It is 90 meters wide and 120 meters long. So this side is 90 meters and this side is 120 meters. Guys, I don't know if these numbers are accurate, but let's just say. So the coach asked the players to run from one quarter to the other quarter diagonally across the field. So they're running this path right here. Do we see our triangle now? I see a triangle right here and a triangle right here. Both have the same hypotenuse. How far do the runners run? If we're running from this corner up here to this corner down here, then I can see my triangle. I have a nice triangle right here. And I know 2 of my sides. So this one is also 90. Remember, it's a rectangle. So, I'm going to write this. So I have 90 squared plus 120 squared equals my distance squared. Okay, that's not too hard. 90 squared is going to be 8,100 plus 120 squared is 14400 equals my distance squared. So I'm going to add these numbers up. So I have 8,100 plus 14400 gives me 22,500 equals d squared. We take the square root of 22,500 to give me d. And now that's, again, our exact answer, but I have no clue how far that is, right? So we're going to take that and put it into find the square root of 22,500. And in this case, it is 150. So that is exact as well because it gave us an exact answer. So it's 150 meters that they're running from one corner to the other. One more problem. A bird cage is a rectangular prism. You guys know rectangular prisms are sort of like cubes, but they're made up of rectangles. So I'm going to sort of draw my rectangular prism here. It's a bird cage, right? So here's my bird cage. It measures 15 inches wide, 25 inches tall, and 18 inches deep. How long of a rod would I need to go from the bottom left front corner to the top right back corner? So basically, I want this rod to go from this corner right here to this corner right here. Well, in order to figure that out, I'm going to use my Pythagorean theorem. However, first, I need to figure out this distance here. So that distance is made from this rectangle right here. So that rectangle right there is 18 by 15. So 18 squared plus 15 squared equals that bottom. So I would say this is going to be the, I don't want to say, I'll say x squared in this case. So 18 squared gives me 324 plus 15 squared gives me 225 equals x squared. So 549 equals x squared. So the square root of 549, I'm going to leave that right there for right now, is x. So this is x right here. Now I need to find this one I'm going to call y, this last distance. So now this one, I'm looking for this triangle right here. That goes right there. So x is the bottom. The height is my other number here. So now I'm going to do this again, except now I have 549, or the square root of 549 squared, plus 25 squared equals y squared. Well, I know the square root of 549 squared is just going to be 549. Plus 25 squared is 625. So 625 plus 549 gives me, so I have 1174 equals y squared. I would take the square root of 1174. And I get, in this case, I only need the exact answer, or the approximate answer. So in this case, y is 34.26. Okay, and it's going to look a lot bigger than any of my dimensions, right? My biggest dimension was 25, but I need a 34.26 inch long rod in order to go all the way that distance. Okay, so let's go ahead and let you guys try these on your own.